Hello, everyone. Welcome to today's NTCA webinar titled Steam Room Principles of Proper Designs. I'm Jim Olson with the National Tile Contractors Association. I want to welcome you and thank you for taking time out of your busy day and schedule to attend today's webinar, which is sponsored and presented by Mapei. Before I introduce today's speaker, I do have a little bit of business to remind you about. Our webinars will be muted. Please use the questions area on your website there and type in your questions. We will answer all that we can. If not all of them, we'll answer them and get back to you at the end of this presentation. So please use the questions area on your control panel and type in any questions you have during the program. If the audio on your computer is poor, please use the number on the invite to this webinar and call and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel. Shortly after the webinars are presented, they will be loaded to the NTCA YouTube channel, and this gives you easy access to watch and or share all current and past programs at your convenience. And just so you know, we have about almost 10 years of library there that are great technical information that you can look and see what's there and very valuable. All right, I'm really excited to introduce today's presenter. He's presented numerous times for NTCA, and he's a fabulous presenter and a great person. Jim Whitfield. He's the FCSI, CCPR, LEED AP. Jim is the Director of Technical Services at Mapei. He manages a strong technical services department that provides support for Mapei's many products, floor covering, and tile and stone installation systems. He is actively involved in the development of the tile industry standards on the TCNA Executive Board and Handbook Committee. He's ANSI A118 ISO committees. Jim's also on the NTCA National Tile Contractors Association Technical Committee. He's the current president of the MMSA Materials, Methods, and Standards Association. In addition, the Construction Specifications Institute, CSI, honored Jim for his contributions to education of the construction industry with fellowship in 2001. Welcome, Jim. Look forward to your program.
Thank you, Jim. I appreciate the introduction. All right, here we go. All right, steam rooms, principles of proper design. Not advancing. Oh, okay. Let's talk about the learning objectives. We'll talk about the differences between commercial and residential steam room design or steam showers, the important design issues in constructing a proper steam room, the importance of the right waterproof membrane, including how to properly select or specify that into a steam room or steam shower using the new ANSI standard changes. Now, when I say that, the ANSI standard for waterproof membranes is still 118.10, but there's been some revision to it, and we'll go into that in detail very quickly. Common issues in steam room design and how to avoid them as well. Merriam-Webster defines steam rooms as a room that is heated to an extreme temperature by steam. Some of the things we'll talk about today will be waterproofing, again, the ANSI 118.10 standard, the E96 method E, I'll explain that in more detail. What a vapor membrane is. We'll talk about how to designate a vapor membrane, as well as a trowel applied, sheet, or liquid applied membrane. The TCNA handbook methods that are relevant to steam rooms. Unfortunately, we'll show some pictures of some ugly showers or steam rooms that have failed. And we'll talk briefly about movement joints as well. The ANSI 118.10 standard. This is a new section added to the 118.10 standard. In the past, we had all of the requirements for steam rooms in the TCNA handbook, and I'll show you that as we get further into this presentation. And that's the only place we listed it. And the requirement was that the waterproof membrane has the ASTM E96 method E at temperatures of 100 degrees and 90% relative humidity. So in other words, we're trying to test the membrane at a steam room type condition. So this section was added to ANSI as well. We took it out of the TCNA handbook and it's still in there, I'm sorry. But we added it to the ANSI handbook so that an architect or designer, or for that matter, you can know how to select the proper membrane for steam room. So a new section was added, 4.6 water vapor permeance. It was passed. It was actually voted on last October. I think we finally got the final votes in the end of November, 1st of December. It'll be published in the ANSI handbook that should be out by coverings. So again, this will be added to the ANSI handbook, and water vapor permeance will be an option, not required, but an option within 118.10. In addition to that, there's optional performance requirements for low perm rating of less than 0.5 perms. For a waterproof membrane that meets 0.5 perms or less, you can add a designation to your ANSI number. So 118.10 TB means for a trowel applied membrane. ANSI 118.10 LB for liquid applied vapor barrier, vapor membrane. An ANSI 118.10 SB is for a sheet applied vapor membrane. That's a big change. Again, the big benefit to this is it can be specified, or you can call out a specific product. This has not actually been published yet, but it'll be out very, very soon. And hopefully people start adding it to their data sheets and so on. So you'll know very clearly it's suitable for steam shower. All right, we're gonna go into TCNA and some of the things that they ask for in the handbook. First thing is the environmental exposure classifications. I'll show you what that looks like in the handbook, but steam rooms meet residential 4, Res 4, or commercial 4. The big difference is residential is for intermittent steam room showers. So in other words, it's used occasionally. COM 4 is for commercial, heavy humidity, heavy moisture exposure. It's considered to be used for continuous use. So like an athletic facility, maybe where you work out, you know, they've got steam rooms, they pretty much run 24/7. Entirely different type of construction. Obviously that one has to be a lot more bulletproof, if you might. So continuous steam shower or steam room, walls and ceilings. This is the environmental exposure classification in the TCNA handbook, or a copy of one. And there are residential as well as commercial recommendations for different types of everything from a fairly dry room, Res 1, to submerged, which is Res 7, like a pool. And the same thing true commercial. You've got COM 1 for commercial dry. Again, COM 4 we just talked about with continuous use shower, steam shower. And it goes as high as COM 7 for submerged applications. If you've never really paid much attention to this page, it's really very helpful. And every single TCNA method has a environmental exposure classification on them. Again, TCNA method SR 613 is for masonry and mortar bed for continuous use steam rooms and steam showers, like an athletic facility, a Turkish bath, Roman spa, or just a spa in general, Roma grottos. Some of the notes within that method: steam rooms are highly specialized applications. Design and installation are critical to avoid damage to adjoining materials and vapor migration. Design criteria may include consideration of necessary insulation and temperature and humidity differentials. Dew point must be considered in the construction of steam rooms. One side of the wall will almost always be considerably warmer than the other side. This is extremely important when you've got an exterior wall too. Again, still SR 613, some more notes. Bonded waterproof membrane, sheet, liquid, or trowel must be continuous and must adequately limit vapor transmission to adjacent spaces and building materials, according to the intended duration of the steam room and steam shower. Use a tile contractor knowledgeable in steam room installation and experience with materials specified. That's within the standard, within the method, I should say. Careful coordination must occur between the door manufacturer and waterproofing. If you have like a glass door going on, obviously you don't like them coming through and drilling through your waterproofing later on. And if so, it has to be waterproofed again properly. Attention must be paid to the installation of the glass door casing doors in general. Minimize penetrations, reseal those that must occur. I just put up a large glass door on a 5-foot opening. Two glass doors that slide side to side. And I got to tell you, I think the glass door manufacturer, at least in this case, because it did have a sill plate, they have a pretty good job of telling you how to keep it waterproof. You know, putting sealant around the penetrations as well as up and down the casing, the sill, etc. So just did that last week actually here, so we could do a video shoot. Waterproofing. Again, TCNA SR 613. This is for continuous use. And I highlighted that. Again, this is in the method, and this is the only place it used to be listed previous to, well, last year and beyond, where it actually lists the low waterproof membrane, 0.5 perms or less when tested with ASTM E96 procedure E, tested at 90% relative humidity. If the waterproof membrane has a permeance higher or greater than 0.5, then a vapor retarder behind the wall assembly is required. And if you look down below, you can kind of see some of the test conditions. And this is why we say E96 procedure E. You see on the bottom right. And again, this is what the method looks like. We'll break this apart a little bit more and look at some of these details in a little bit more detail. Check with the membrane manufacturer for suitability for applicable conditions, as not all membranes are suitable for steam, high temperature, and or chemical exposure. I've heard of some membranes actually melting due to the steam. Some waterproof membrane manufacturers require the use of vapor retarder in addition to a waterproof membrane. I think everybody's kind of getting away from that, but again, good reason for you to ask. If they require that, it'd be wise to add it. Of course, well, we won't go into that right now. Consult the manufacturer for any requirements when waterproofing a steam room. When used, a vapor barrier must, it's just already mentioned this, weather lap itself or ship lap and lap onto the shower pan. So this is a shower pan, a sheet shower pan, like a Chloraloy if you might, that's already installed in a mortar bed, and then the membrane has to overlap on top of the membrane that's the shower pan membrane that's sticking up. We want to make sure things are flowing positively. And of course, if water comes down the wall by chance, in the case of a mortar bed, and it hits the waterproof membrane, you want it to go in front of the shower pan membrane. You do not want it to go behind it. Bad idea. You're going to have all kinds of damage. If a vapor retarder membrane is required, integrated bonding flange cannot be used. So an integrated bonding flange drain is what we're talking about there. So you can't be waterproofing on the top of the mud. It has to be from the bottom. Oh, come on. I just got a thing to update something. How does this happen right in the middle of a webinar? It's inevitable, isn't it? Follow waterproof manufacturer's directions for interfacing between the drain and other membranes. Design professionals specify adequate insulation in the walls and ceilings to reduce condensation. Consult insulation manufacturer for application suitability. So quite frequently, they're going to put insulation in there as well, again, to protect the membrane so that something doesn't melt it or something like that, like I just mentioned. So if that is designed that way, make sure you get one that's recommended by the manufacturer for a steam room. Again, for continuous use, when you've got a mortar bed, the easiest way to do that is to kind of put a slip joint in there. So seal all membrane penetrations with appropriate sealant according to membrane manufacturer's requirements. Specify slip joints at changes of plane. So what that looks like is you actually let's talk about a sheet membrane because that's probably the easiest way to explain it. You take that membrane, you tuck it into the opening so that it actually is U, if you might. And then a backer rod would go on that and sealant. So easy way to make sure that that can move if it has to. If it is mortar bed, the metal lath has to be cut at all slip or movement joints. So like inside corners, good example. In the case of steam rooms, the ceiling has to be sloped. The requirement in SR 613 is 2 inches per foot. That's to avoid condensation dripping onto the people sitting in there or enjoying the space. So in large areas, you can slope from the center, go down multiple walls or 2 walls. But it is critical that you slope the ceilings. Matter of fact, I'll show you some pictures of not the best looking steam rooms that weren't sloped. Slope shower pan membrane 1/4 inch per foot to the weep holes of the drain. Shower receptors, curbs, seats, niches, anything like that really should be sloped to avoid water building up in them. Now we're going to talk about residential. This is probably the one we're most familiar with and commonly is done over wood or metal studs, usually with CBU or backer board or mortar bed for that matter in residential. Steam rooms or steam showers. I kind of consider most of these in residential steam showers since they're a lot smaller. Not really built for multiple people, but in SR 614, the method for residential steam showers, it requires the design professional to specify adequate insulation of the walls and ceilings to reduce condensation and consult the insulation manufacturer for application suitability. Seal all membrane penetrations with the appropriate sealant according to the membrane manufacturer's requirements. And if you are using a sheet membrane, I know a lot of us have rings and things like that to make that a whole lot easier. Just slide it over there and seal it off. And then thin set that to the existing membrane. SR 614 for steam rooms and steam showers and steam rooms framed with wood or metal studs. Specify mortar bed walls option when wall flatness is critical, such as when the walls have tile with one edge longer than 15 inches. So we now kind of consider large format tile. Maximum stud spacing 16 inches on center. All right, now we're going to look at a few steam showers. Here's one that is not sloped properly, and you can see the effect. Would you want to be sitting underneath that? Probably not. Getting rained on the whole time. That's why we slope the ceiling. Another one. Mold. If you don't pay attention to moisture and steam and vapor for that matter, all kinds of things can start growing in there. This is just outside the door when they open the door. That's what it's done to the drywall above it. All that needs to be in consideration. This is a selection of a wrong product. It's another manufacturer's single component urethane grout. This was a $30,000 doctor's steam shower at his home. And you can see how steam got through the grout product and just collected behind the glass tiles. Needless to say, he did not like that look. This thing was kind of the door on it was an arch. It's very, very interesting, very cool looking shower. Much larger than what you can see here. We're actually inside there taking a picture. But unfortunately, it had to be tore out and redone because steam got back behind there. This one I'm going to show you a steam room gone bad. You can see the mold already occurring on the curb. Why? Well, there's a sheet membrane there. Problem is there's nails going through it. You see 2 nails right there. That's to the shower side, by the way. That is not to the outside. That's on the inside. Water damaged lumber. Membrane that's now brittle and splitting, cracking, just because it's aged. Unfortunately, mold on the seat as well. That means that the seat's molding underneath it. Another poor design feature, and that would be a hill to climb up for the waterproof membrane. In other words, waterproof membrane gets to the drain, but then it's got to come up about an inch. That's not going to happen until that thing fills up with an inch of water. Not something you'd want in your house, I'm sure. Going to smell a little bit. Here's what that pan looked like once everything was taken out. A lot of damage. Fortunately, this is what it looked like when a good installer got back in there, was able to do the repairs. You can see the mortar bed pan. Finished, reinstalled. I don't think it can be said enough. You know what water can do in erosion, in the case of like the Grand Canyon. Water management is critical. It can be extremely, extremely destructive to homes and or commercial buildings. This is not like just waterproofing a shower, even though that's important. Steam rooms are very, very, it's critical they be done correctly, critical, and with the right materials. We'll talk about movement joints in ANSI in the A118.01. It is not the intent of these specifications to make movement joint recommendations for specific projects. The specifier is responsible to specify and detail movement joints and show locations. That's in ANSI as well. All openings for movement joints shall extend completely and directly through the tile work down to the structural backing. The membranes can remain continuous still, but like lath as an example, you'd want to cut that. Movement joint design and spacing shall comply with TCNA method EJ171. Let's talk about that a little bit. This is EJ171 in the TCNA handbook 2024. It's just off the top of my head, I'd say an 8-page document, maybe 7. It's a pretty good sized document though. Included in it is a location and frequency of joints, the joint width, what materials should be used for that joint, what type of sealant as an example, interior, exterior, all that. One fairly new picture we put in 2018 was actually kind of highlighting or showing you where the movement joints should be. Perimeter and field movement joints within the installation are essential and required. Not a good idea. Not if you get around to it. Like, it's essential. It has to be done. Because of limitless conditions and structural systems in which tile can be installed, the design professional or engineer shall show specific locations and details of movement joints on the project drawings. Preparation of the opening left by the tile contractor and installation of backup strip and sealant should be specified in the caulking and sealant section of the job specification. So it's got good direction for design professionals as well. And I know this one went pretty fast, actually, a lot faster than I thought it would. In summary, steam's more powerful enough to drive a train. It's that powerful. So carefully follow TCNA and ANSI standards regarding steam rooms. Know the finer details of steam showers. What are the appropriate membranes, waterproof membranes, setting materials, grouts, and sealants. Understand steam's effect is powerful. It can easily destroy walls, floors, and cause major leaks within the household. Thank you. And I'll mention that a lot of those steam room pictures came from NTCA members. And so I'd like to give them compliments and point their companies out to you. So
Great
With that,
job. Great job. And
thank you.
thank you for pointing out NTCA members. But I just want to make sure you know that we always work together, all of our associations and groups here in the United States. I had the opportunity to go to Sebisama this last week in Spain. It's their show similar to Coverings. I'd like to pat you all on the back because we are way ahead of them in regards to installation and methods and standards. And Jim, you're a big part of it. Thank you. Means a lot. Hey, I do have a bunch of questions here for you, if you're ready.
Good, good.
All right.
Sure.
The first one is, so can we still use the pre-sloped shower trays that are waterproof?
If the manufacturer recommends it.
You know what? That's a really good
it,
question. Everybody should understand. Manufacturers' recommendations always supersede any other methods and standards. I mean, they're the ones warranting it and standing behind it. So if they give you the okay to do it or whatever, that's their standard, right, Jim?
Right, exactly. And the SR 613, you could not use it, and maybe this is what they're getting at too, is an integrated bonding flange drain. And the reason for that is because your waterproofing is below the mortar bed, not at the top. And so you're tying in at the weep holes, not at the bottom at the drain collar itself. I hope that answers that question.
So Ike, while we're answering other questions, if you have more that you'd like to add to your question, just type it in and we'll get to it in a little bit. Thank you. All right. Is a CBU wall ever approved for commercial application?
I'm sorry, Jim, repeat that.
I'm sorry. Is a CBU wall ever approved for commercial applications?
It is not in the TCNA handbooks. The only way I can answer that question.
Okay. So the only way it would be approved if it's by a manufacturer, right? Their recommendation or their
yeah.
That would be the only way at this point.
And if it's continuous use, I doubt you're going to get somebody to recommend that.
Yeah. All right. What grout cannot be used in a steam shower?
Ones that the manufacturer doesn't recommend.
we're
well, unfortunately, it's the right answer. You know,
do you approve urethane in a steam shower? Grouts?
I don't have a urethane grout, so I could not answer that. I have a single component, and it would not be suitable for intermittent use like a shower. It's suitable, but not for a steam shower.
Right, steam shower.
I can put my epoxies in there, any of my cements, epoxies, things like that, no issues.
Perfect. All right. In the case, all right, in the failed glass steam room, was the failure because of the thin set that was used? If the tile and glass is not waterproof, then vapor or water is always allowed to get behind the tile. Therefore, how would you allow the moisture to be able to drain properly? Or is there a method to avoid moisture to get behind the tile? How about if I do this in parts? In the failed glass steam shower that you talked about, was the failure because of the thin set that was used?
No.
Okay. All right. Next part of this question is, if tile and glass is not waterproof, then vapor or water is always allowed to get behind the tile. Therefore, how would you allow the moisture to be able to drain properly? Or is there a method to avoid moisture getting behind the tile and glass?
So let me answer that about the glass. I think it's probably the easiest way. Couple things about glass. Well, let me talk about that installation. That failed because the single component urethane grout was installed, and the manufacturer said that you could use that steam shower within X amount of days, and it was too early. So they changed their recommendation after that failure and extended it. I can't remember how much further out. I really don't know. I got asked to go look at that project because the competitor whose grout that was we were both selling to the same distributor, and he and the distributor asked me if I'd go look at it. So that's the reason I got to go out there. So glass is pretty low absorption. I mean, you're not going to drive much through glass, and the assembly, the only place that's really waterproof is at the membrane. So you can, I mean, well, one other thing I'll say about glass right now, just because I had to bring up glass. Glass is extremely expansive. So it is the most expansive tile that we have. So it is critical, very critical, that movement joints be done correctly. I always recommend they be done closer than normal. In other words, we used to recommend every 8 to 12 feet. And I would lean towards the 8-foot mark as far as frequency. Anyway, that's a kind of a little bit of a soapbox of mine. Yeah, tile and glass are not the barrier. I mean, you got to realize that most of the moisture is going to run off there anyway, just like a drain, right? If you have a shower pan that works properly, most of the water is still going to go in through the top. Just because you're sloped right there, the tile's low absorption, when water hits it by the gallons, it goes right to the drain, not through the mortar bed, and it does not all go through the mortar bed and hit the membrane down below. So the same thing's true of walls, certainly, because we got gravity on our side as well. I hope that answers that.
Well, we'll see. I do want to make sure everybody understands that all the manufacturers of these setting materials and materials that you're using, they actually have a technical, they have a whole technical division that you can actually email, you can call, you can ask these questions. If you're using a company's product, reach out to them, reach out to the distributor that you're using, and make sure that it's used properly. So really important. Definitely. Okay, next question. Can you talk through what you said about integrated drain and what to use instead? Also, are there any specs for glass doors in steam rooms?
Are there any what? Glass. Well, let me come back to glass doors. Let me talk about the drains first. So there's an integrated bonding flange that sits on top of a mortar bed or on the top of a shower pan, a pre-manufactured shower pan. So it's at the top, and water goes into it. It doesn't weep. Water goes into it as it runs through the drain. That's it. Then there's a center point drain, which is, you saw the drain collar in that shower or steam room that was being rebuilt, the white plasticky collar. That would go there, and the drain would be at that level, if you might, and the waterproof membrane is to that drain, that lower area, but the drain itself is sitting on top. So in other words, you turn it and you adjust it to make it meet the top of the tile. So they're two totally different animals. One's below a mortar bed and one would be on top of, for instance, a pre-manufactured shower pan.
Can I just mention to everyone, if you see the screen right now, thank you, questions, Jim Whitfield's email address is there. You will get a thank you from me with my email address on it. If you have more questions after we're done here, you can definitely send questions to me and Jim and I will answer them, or you can go straight to Jim and he will answer them. But important that you know we're here for you. So the second part of this question was, are there any specs for glass doors in a steam room? And I guess what I'm saying, you know, is a glass door on a tub shower the same as a steam room? I'm sure they would definitely need to get the proper door, right?
Yeah. Usually, if you want a steam room, you're going to have to seal it off completely. So, for instance, what Jim just mentioned, a tub, it really wouldn't work because the steam's going to come out through the top of it, right? So, yeah, you're not going to just run down to any old store and get the proper door for a steam room. Not that I can think of. I mean, you've got to have an enclosure area, enclosed. Otherwise, you're not going to build up steam.
I would think if you're working with a glass company that does glass doors for showers and tub surrounds, they're also going to do steam and they're going to recommend the proper door. So
yeah, correct.
That's where I would go with that one.
I agree.
All right. This question comes from an NTCA member here. I've seen several failures at the steam valve. They've moved to a 2x2 sheet membrane for this area. Epoxy set tile and epoxy grout with a soft joint and a 2-foot perimeter. He believes the heat is deteriorating the WP waterproof membrane, and the extreme contraction also contributes. Your thoughts?
I'm not sure I followed all that. I apologize.
That's okay. I'm going to read it slower because I read it twice already. He has seen several failures at the steam valve, and they've started to move to a 2-foot by 2-foot sheet membrane for this area. So right around the steam valve.
Sure.
They epoxy set the tile and epoxy grout with a soft joint at the 2-foot by 2-foot perimeter. He believes the heat is deteriorating the waterproof membrane and that the extreme contractions also contribute. Your thoughts?
It could. Yeah, I think it could. I definitely think it could. Again, depending on what the finished material is too, some more than others. But I definitely could understand the need to properly waterproof right around where the steam pipe, if you might, is coming in. Absolutely. And like I said, I mean, it's steam's known to melt waterproof membranes. It's definitely has that ability, especially over time.
Okay. So this isn't a question, it's just a statement. I'm assuming maybe you'll understand. It's just transom windows, etc. Explaining what a transom window is or how that works in a steam shower?
It'd be a window, yeah, that's above like the header, above the door header, and opens up there. I'm not, obviously wouldn't be a big fan of having a window in a steam shower at all. But I've seen them built before with them. I'm not sure how you'd waterproof it properly.
I wouldn't even understand why you'd want that.
No, unless you wanted to open it up to let the steam out, the transom.
Yeah, maybe that would help dry it out when you're not using it.
Yeah.
Ashley, I'm not sure how to answer that. All right. We've got thank you for this information. We've got, how about this one? The drain on these pre-slope trays are installed from the top, hence the question he asked earlier, the Ike. I can't remember the question now.
I think it's about the integrated bonding flange.
Oh, yeah.
So,
I don't
again,
think
that's not going to work real well in commercial.
Ike, I think it would be great if you send an email to myself and Jim and give us as much detail to your question as you can, and we'll get back to you. All right. Are there any standards or test methods for testing the room as a whole or system versus just an individual component like the membranes?
I'm sure there are. I don't know what that would be. I mean, you can test the seal, if you might, of a building. But I really honestly would not know how to test a space.
Yeah.
Not my expertise, if you might.
Steve, I'm sorry. Don't have a great answer for you. Send me an email and I'll see if I can do some research. Thank you. What grouts are specified for steam showers? This person says they're sorry they might have missed this, but what grouts are specified for steam showers? I know you said
I think in almost all cases, most of the cements are going to be recommended: sanded, non-sanded, high performance, epoxies. I guess, yeah, I mean, you're at 180 degrees roughly to get steam, so I don't think you're going to exceed the temperature limits of an epoxy, but it's worth asking the manufacturer, make sure they recommend it for that purpose, but I think most of them would. Single component grouts, I think that's where you really, pre-mixed grouts, if you might, and there's a new standard coming out soon with pre-mixed grouts as well as installation for pre-mixed grouts. It would not list necessarily steam rooms, but I think I'd really do my due diligence and make sure the manufacturer recommends it for a steam room.
Okay. All right, so this question has to do with the person earlier that asked about water behind the tile. And he
Okay.
says, well, the water behind the tile had nothing to do with the membrane used, correct?
Correct.
I agree.
It just got through the grout before it was cured.
Yep.
The steam shower was used too early, so it wasn't a. Yeah, it just got through the grout because it was still more porous in the curing stage.
Unless there's a crack from a wall or something, right? I mean, that the water would get behind there, but it's nothing to do with the membrane. The membrane's not leaking.
Yeah, and I think you could have water collect back there if you did not have good coverage of thin set, for instance. But our latex modified mortars are fairly low in absorption, and if you've got good coverage, it's going to take a lot to get to a tile, a grout, and mortar that's polymer modified. But if you had large voids and poor coverage, which you should have 95% coverage, is what's required by ANSI. Behind a tile in a steam room type condition, in wet conditions.
Okay. This person asking, did I hear that when using a mortar shower pan, that the waterproof membrane needs to be applied below the mortar as well as obviously on top of the mortar pan?
No. In SR 613, it is for that method, shows the waterproof membrane at the bottom, on top of pre-slope, going towards the drain collar, but the mortar bed on top of that. So you've got another 1.25 inches of mud, if you might. And it does not show a membrane on top. You could if you chose to, but I don't know why. I'm not a big fan of that myself, but we're talking specific to the TCNA methods, not what you could also do. These are steam room methods.
So nobody's recommending you do that. That's up to you, right? The standard that's written is that it goes below the mortar.
Bed.
Yep.
Yeah.
Okay. All right. Okay, we're going back to, I think, the water behind the tile, and this person saying, in other words, the failure happened at the surface level or grout.
Yep. It went through the grout.
Yep. Okay.
And of course you could see it because it was glass. If it wasn't glass, you wouldn't have known it was there.
Victor, you asked when are we going to load this into our YouTube channel, this video? It will be there by tomorrow afternoon. All right, another thank you. And Stefan on the water behind tile said, no sweat, thank you both. So we're good to go there.
Good deal.
That's all our questions today, Jim.
Jim, I think this really shows how a lot of people really, have a lot of questions when it comes to steam room and steam room construction. And I think it's a good subject, because they're not doing them very often. Now, it's not something you do on every house by any means. And there still are a lot of questions out there. Use your standards, use your methods, and study them if you're doing a steam room. That's fact.
I agree with 100%. And do not hesitate to talk to the manufacturers of the products you're using. Make sure everything's being done correctly. Maybe even talk to, other people that maybe manufacturers of products you're not using and get their ideas. But don't hesitate to ask questions. It's very important in our industry. So
yeah, agreed.
Yeah.
Agreed.
Well, thanks everyone. Thanks, Jim. I just think this was a great topic, something we need to talk more about, and hopefully we'll do more in the future. Everybody have a great week. We have our next webinar. Let me see here. Our next webinar is on March 21st. You'll have an invite coming soon, and I really appreciate you all attending. Thank you. Take care now.
Thank you.